Dear student, today we will discuss organic chemistry. Before going through this chapter, let's know about the word organic. What do you mean by organic? Now, organic means pertaining to life. When little chemistry was known, people thought that organic substances like starch, cellulose, etc. are prepared from only living organisms, and the chemistry dealing with them was called organic chemistry. But since in 1828, chemist Friedrich Fuller prepared an organic compound urea from an inorganic substance ammonium cyanide in the laboratory process, the concept was totally discarded. Ammonium cyanide NH4CnO on heating gives urea NH2CONH2. This is an inorganic substance. This is an organic substance. Okay. Also, Kolbe in 1845 prepared acetic acid from its constituent carbon, hydrogen, oxygen. Bartholow prepared methane from its constituent. Okay. Now that's why. What is organic compound? Now, organic compounds are essentially the compounds of carbon, and the study of carbon compounds and its derivative is called organic compound. Okay. Now we will know about unique nature of carbon atom. One number, tetravalency of carbon atom. Tetravalency of carbon. And second one, catenation. Here we will discuss tetravalency of carbon atom and later on catenation. Tetravalency of carbon atom. Carbon has electronic configuration 2, 4. In the outer shell, it has 4 electron pair. 4 odd electron. It forms with 4 another atom to form covalent bond. Okay, that is like in methane CH4. Another also with another atom it forms covalent bond. Now we will know about catenation. What is catenation? Now, catenation is the property of self-linking of an atom to form covalent bond vied through carbon-carbon single bond, double bond, triple bond, etc. Okay. This is the property of catenation. Carbon shows its maximum strain towards catenation due to the small size and carbon-carbon strain. Carbon-carbon bond strain. Okay. Silicon atom also shows catenation property, but this is not too much profound because it has bigger size. That's why the silicon and another atom bond is not too much strong than or compared to carbon atom. Okay. Now formation of straight branch or ring chain will be discussed. Now carbon atom reacts with another atom, forms straight branch, ring chain, etc. As per example, C. Okay. This is a straight chain. Branch chain, CH3, CH2, 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 CH3, CH3. This is a branch chain. Ring chain like cyclohexane, or this is CH2 CH2 CH2. This is cyclohexane. These are the ring chain. Okay. Now later we will discuss about isomerism. Carbon. What is isomerism? Carbon shows tetrahedral arrangement of its valences and shows isomerism. That is carbon atom have same molecular formula but different spatial arrangement of its valences makes isomerism. As for example, glucose and fructose both have molecular formula. What is molecular formula? C6H12O6, but they have structurally different and shows isomerism. If we represent it in Fisher correction, then it will look like glucose. It is molecular formula. Okay, molecular formula of glucose fructose, molecular formula. now if we represent it in Fisher correction, the structure of glucose would be look like CaO, HOH, OH, HOH, HOH, CH2. Okay, this is glucose. And fructose, CH2OH, C double bond O, HOH. Sorry, this would be OHH, OHH. Okay, OH, OHH, HOH, HOH, CH2. This is fructose. Okay, they are isomerism. They are enantiomer also. Enantiomer is a kind of isomerism. Okay. Now we will know about kinds of organic compounds. Okay, organic compounds have been classified as hydrocarbon and its derivative. Hydrocarbon. What is hydrocarbon? Hydrocarbon are the compounds composed of hydrogen and carbon. Okay, and its derivative like aldehyde, that is CaO, ketone, aldehyde CaO, ketone C double bond O, OH, alcohol, ether, single bond O, ether. Okay, ester C double bond O. These are the derivative. Now hydrocarbon can be classified into two categories. Hydrocarbon. Okay, see aliphatic hydrocarbon. Second one হচ্ছে alicyclic or ring chain hydrocarbon. Okay, or ring hydrocarbon. That is, this is not closed but it is closed. Okay, aliphatic or open chain, alicyclic or ring chain or closed chain. Okay, aliphatic can be classified into two categories. First one, saturated. Second one, unsaturated. Okay, saturated is being alkane, unsaturated is being alkene and alkyne. Okay, alkane saturated, alkene unsaturated, alkyne unsaturated. Alicyclic can be classified into two categories. First one, ring chain. Second one, aromatic. As for example, ring chain organic compound. As for example, CH2 single bond CH2 single bond CH2. This is similar to that is okay. Also another cyclohexane. This is also ring chain compound. Aromatic. What is aromatic compound? Now, aromatic compound are those have equal number of electron and have plane of symmetry are called aromatic compound, like benzene, toluene, phenol, as for example. Okay. Equal number of electron, that is 6n plus 2 number of electron. Examples: benzene, okay, toluene, okay, phenol. If we write it here, phenol, okay. These are the example of aromatic compound. Now we will discuss why it is saturated hydrocarbon. Alkane. As for example, alkane example: methane, ethane, propane, butane, etc. There are as many long chain. Okay. Alkene, as for example, CH2 double bond, CH2 ethylene, alkyne, CH triple bond, CH. Now we will know why it is saturated. It is saturated hydrocarbon because here the valencies of carbon atom is totally filled up. That means here carbon atom forms 4 covalent bonds with hydrogen atom. Okay, that's why here it fills its octet. Okay. Okay. And here the unsaturated, here this is unsaturated because here the carbon atom may join with another atom, with oxygen or another fluorine, chlorine, bromine. Okay, not fluorine, it does not react with fluorine, but chlorine, etc. Several another atom can react with it. That's why it is unsaturated. Okay, clear? Okay. So now we will know about functional group. Functional, FUNCTION, functional group. A functional group is an atom or group of atom that spatial arrangement determines the chemical property of the compound. As for example, OH means alcohol group, C double bond OH means carboxylic acid group. Okay, a different functional group have different chemical behavior, chemical and physical behavior also, but the same functional groups in the homologous series have same chemical behavior. Okay, as for example, if we take in the homologous series of alcohol, that is methanol CH3OH, C2H5OH, ethanol C3H7OH, propanol, etc. All of this have same kind of behavior. Okay. As per example, methanol on reacts with HCl gives methyl chloride. Against it is also reacts with C2H5Cl and it also reacts with C3H7 C3H7Cl. Okay. This is the characteristics of functional group. Now we will know functional group. We will know about homologous series. Homologous series is a group of series that differs successively by CH2 group. As for example, if you take this example, that is CH3OH, C2H5OH, here the difference is only CH2 group. That differs by atomic mass 14 m. How 14 is obtained? 12 plus 2 into 1. Okay, that is homologous series. Another example, as for example, CH4 methane, C2H6 ethane, C3H8, C3H8 propane, methane, ethane, propane. Here the difference is just only CH2 group. Okay, C2H6 plus CH2, that is C3H8. And another methane, ethane, propane, butane, hexane, heptane, octane, nonane, decane. Okay, another long chain series will be found. That's why the characteristics of homologous series is very crucial. If we detect the behavior of one two element of its group, then we can detect the property and chemical behavior of another element from this group. This is very crucial point. The physical property, the physical property, the physical mass or molar mass differs by in a homologous series by just 14 m. Okay. This is the very important utility of homologous series. Another several homologous series also have, as per example, for alkene group, the first element is ethylene. Second one, what is second one? Ethylene. Propylene, CH2 double bond CH double bond CH2, CH2 double bond CH double bond CH2, and in this way we can get several organic compounds of the same homologous. What is this? Now here this is the alkene homologous. Okay, CH2 double bond CH double bond CH2, ethylene, propylene, etc. Its UPEC nameकरण, its UPEC nomenclature will be determined later on after this completing. Okay, later on we will discuss about this. Okay, etc. This is the all information about homologous series. Now we will discuss nomenclature. Okay, now we will know about nomenclature. This is very interesting, that should be remembered to all of you and practice much more for recognizing and familiar with chemical compound, organic chemical compound also. Nomenclature: the system of assigning or nominating an organic compound is nomenclature. Okay. Now, for nominating or assigning an organic compound, we have to write its structural formula. Then we should follow three things. First one, root word. Second one, suffix. Third one, prefix. Okay. Root words means for one carbon atom. For one carbon atom, that is meth. METH, meth. Two carbon atom. If the carbon-carbon long chain has one carbon atom, then the numeric root term is meth. Okay. For two carbon atom, eth. And similarly 3, 4, 5 meth, eth, prop. 4 but. 5th pent. Meth, eth, prop, but, pent, hex, heft, oct, non, dec. At least these 10 ones to be remembered. Then suffix. Suffix means if the homologous series is alcohol, then suffix will be al. Okay. Al or all. Anyone. Prefix, if the substituted group, is 1, 2 or 3, then prefix should be di, tri, tetra, hexa, hepta, octa, etc. This type of prefix to be added during nomenclature. Let's do a task for nominating an organic compound. Let's see. Suppose C4H10. C4, okay. C. Single one. Here C4, H10. H. This type of here only here the structural formula is given. From molecular formula we can get two types of formula here, because here it is not found. Here this formula would be this, because it is alkane group, alkane homologous series. That's why this structural formula will be found. And now we have nominating it according to UPL nomenclature. Let's see. At first we have to write the series according to numeric number. Then 1, 2, 3, 4. That is 4 means 4 carbon atom means but. Okay. Alkane, that's why suffix butane. Alkane, in butane. Okay. Let's take another example. Let's see. Suppose there is CH3, CH2, CH2, CH, Cl, CH double bond CH2. If the nomenclature, what will be the nomenclature of this compound? At first we have to see the structure formula very carefully. After then we have to see that the minimum number of carbon atom should be kept in the head of the functional group carbon atom. Here the functional group carbon atom is this because it is alkenes rich, okay, and also it should be kept in mind that substituted group should be found in short distance, okay. That's why if we write the according to number, then 1 2 3 4 5 6, okay. 3 chloro, at first prefix will be right 3 chloro, 6 means hex, in 3 chlorohexene. This is the UPAC nomenclature of this compound, of this organic compound, okay. Let's see another example. CH3, CH, Cl, CH2, CH2, CH, Br, CH2, 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 Cl, OH. CH2, CH3, if the nomenclature of this organic compound is to be done, then how can we number the carbon atom? Here the substituted group, here is chlorine, here is bromine. At first we have to keep in mind that the substitute group should be found in short distance, and also we'll have to keep in mind that alphabetical order of the substitute group should be in difference. Here the bromo means B, alphabetical word, and chloro means C, okay. That's why bromine should be taken, considered, should be taken, okay. Let's number 1 2 3 4 5 6 7 8 9, okay. And also it should be kept in mind that carbon carbon long chain will be considered, okay. And UPAC nomenclature will be 5 bromo, 8 chloro, 5 bromo, 8 chloro, non N, okay, N, A, 5 bromo, 8 chloro, non N, ठीक है, okay. Thank you.